This is a fundamentally new way to travel. And when you think about it, Seagliders are really the first new mode of transportation, entirely new mode since the helicopter, almost 100 years ago now.
Welcome to Sustainability in the Air, the world's first podcast dedicated to sustainable aviation. I'm your host, Shashank Nigam, the CEO of Simplifying. On this show, I speak with aviation leaders, innovators, and policymakers driving real action, separating the signal from the noise to spotlight what's truly moving the industry forward. The same focus that is at the heart of our new book, Sustainability in the Air, Volume 2. In it, Dirk Singer and I take stock of how far the industry has come and how far we still need to go. With the global carbon budget potentially running out by 2032, the clock is ticking. But the most promising solutions today aren't just environmentally sound, they are economically superior as well, from SAF and contrail mitigation to direct air capture. The book offers a practical roadmap for aviation's journey to net zero. Get your copy today. Link in the show notes. My guest today is Billy Thalheimer, co-founder and CEO of REGENT, a company creating a brand new category of transportation, the Seaglider. These all-electric flying boats travel just above the surface of the water on a cushion of air, combining the best of maritime and aviation technology. It's an idea that sounds like science fiction, but Billy and his team are already testing full-scale prototypes in Rhode Island and have over 10 billion in orders from airlines, ferry operators, and even energy companies. Their goal is to make regional coastal travel faster, greener, and more affordable. In our conversation, Billy and I talk about how REGENT is reimagining short-haul travel, why their pilots are actually mariners, and how this technology could change everything from daily commuting to disaster relief. I hope you enjoy this interview. Billy, it is fantastic to be finally speaking with you after so many attempts to visit you, to meet you, and I cannot tell you how excited I am about having the first Seaglider on the show.
Yes.
So for the listeners who are not familiar, you're creating a new category of transportation that's between boats and aircraft. Can you explain to those F geeks who are listening, not ship geeks on this podcast, what is a Seaglider?
Absolutely. Well, Shashank, thanks for having me and for hounding me over the past couple of years to get on the show. Love the show and excited to be here today. So you're absolutely right. So I'm Billy Thalheimer, co-founder and CEO at REGENT, and REGENT builds the Seaglider, which is exactly like you said, sort of part boat, part plane, a little bit in between. A Seaglider technically is a type of vehicle called a wing-in ground effect vehicle, acronym WIG or WIG. And so Seagliders are a type of wig. They're actually hydrofoiling wigs. So I think we'll get into that a little bit later in terms of how they work. But basically, they are all-electric flying boats that always fly within a wingspan of the water surface on a cushion of air called the ground effect for dock-to-dock, over-water regional transportation. So Seagliders are addressing transportation struggles on these regional routes between, say, 50 and a couple hundred miles for the 40% of the world's population that lives in these coastal communities. Everyone has that painful route, whether it's along a coastline or across a body of water that's just very difficult. And Seagliders will simultaneously be the fastest, cheapest, greenest, safest, and most comfortable way to travel on these routes.
Wow. So you said 40% of the world's population lives on a coast. I can imagine a country like Australia where everyone lives on the coast, whereas a country like the United States where, yes, the coastal cities are huge, but then there's a lot of population in the middle. Is REGENT replacing an existing mode of transport, or is this a new way to travel?
this is a fundamentally new way to travel. And when you think about it, sea gliders are really the first new mode of transportation, entirely new mode since the helicopter, almost 100 years ago now. So sea gliders are really solving a problem, a gap in the market that exists today. For example, I grew up in the Boston area. Regent is located in Rhode Island today. So I've done that Northeast corridor between, say, the Boston, Rhode Island, and New York quite a bit. And so if you look back to the 1950s, like that route would take, several hours driving in an old car, flying in an old DC-3 or whatever. And if you look today, it's the exact same time. Like everything about the world has changed, medicine and the internet and, AI, but that route still takes the same. Maybe that route takes longer, honestly, because we have more traffic and you have to get to the airport even earlier and you have, more robust security at the airport and all these things. So there's truly a hole in the market that exists in terms of the commercial market between your cars and your boats and even your trains, your rail, and all rail in the US and the majority worldwide is obviously low speed rail for the short routes. And those are great, 10, 20, 30 miles, 50 miles start to get up towards an hour, probably want something faster. And then aviation, commercial aviation, for these regional routes like this, you are in the airport longer than you're in the airplane. You can't even flip your laptop open and get on the Wi-Fi before you come back down. So, like, clearly that is an unoptimized way. They all take the same amount of time. They're all somehow cost the same, which I don't understand. And so there is really this need in the middle of the market for a transportation solution that is faster and cheaper. And then since we're coming at it now, in the 2020s, we can also make it greener and more comfortable and safer too. So we're doing all of those at the same time.
You're absolutely right. And very similar to you, I have done this Boston, New York, DC route often. 20 years ago, I started my career in Cambridge at an MIT startup. And I remember taking the Chinatown bus at that time.
Yes.
Down to Manhattan. And it was about 4.5, 5 hours, no Wi-Fi, no power outlets. And I remember being on the first Emirates A380 flight to JFK, took the Chinatown bus from Boston. That was in 2008, 2009, around that period, 2007 actually. And then just a few weeks ago, I came to meet Tony Fernandez at AirAsia in New York City, took the bus down from Boston and took Flixbus. The thing that changed was there were power outlets and Wi-Fi, but the travel time was exactly the same. And the moment you hit Manhattan, oh my goodness, that's another 2 hours, right?
Exactly.
Down. So this hits close to home. I completely relate to what you're saying.
And what we found is, all around the world, everyone relates to what we're saying. Humanity was really colonized and settled on the coastlines. The oceans used to be the connective tissue of humanity. And in the logistics space, 90% of global logistics goes over the waters and the container ships. So in many ways, it still is. And obviously mobility has moved to the center and on land and through the air. But it's like we have these waterways. Let's reinvigorate them. Let's use them because to some extent, like, why build roads and rails and airports when you have this open water and we can leverage that open water for this very efficient transportation, flying on that cushion of air like the birds do?
So tell me about this cushion of air. I'm very intrigued by this wing in ground effect. I did research for the interview and I was very fascinated. I had a chat with Japan Airlines, who I believe is an investor with you guys. And the folks from there were really excited about this wing in ground effect. What is this? You take off and you're like flying right above the surface of the ocean. Is that it?
Yeah, so ground effect is an aerodynamic phenomenon that all flying things experience, whether birds or aircraft or sea gliders, that exists when you're within a wingspan of the surface of the water. And it increases your lift, it decreases your drag, just makes your flight more efficient. The sort of simple way to visualize ground effect is to say that high pressure air under the wing that's lifting up on the wing, that's what keeps the airplane in the air. So that high pressure air under the wing, Newton's laws, equal and opposite reaction, needs to push down on something. And so it turns out that flying low over the water, that high pressure pocket of air is more efficient when it pushes down on a surface like the ground or water than it is just pushing on more air beneath it. And so that is the ground effect, is riding on a cushion of air. And that's why when you see birds flying over the water, they're flying so low to the ground because they're able to sort of pressurize that cushion. So a ground effect vehicle or a wing and ground craft or a WIG stays on that compressed cushion of air all the time and therefore gets these flight efficiency augmentation that results in either higher payload or longer range or both. And so that's the really interesting thing from a physical perspective. From an operational perspective, it means we're always within a wingspan of the water. A Seaglider is typically flying at about 30 feet altitude over the water. And so that means we're actually flying below the height of a sailboat mast or below the height of a cruise ship or those cargo ships I was talking about. So we are very much in the maritime domain. And because we're staying over water at all times and flying at such low altitudes, the operations of the vehicle are more like a boat than a plane. And actually, there is a robust regulatory pathway, both in the US and internationally, that casts all wing and ground craft, all WIGs, as vessels and not aircraft, both for the craft and for the crew.
I love this. I want to get back into the technology, but I have to share that just a few weeks ago, I had Mark Allen from Electra come on this. And the interesting thing is, I cannot ignore the fact that blown lift technology is, again, a lateral way to think about flying. Mark told me the same thing. Flying has not evolved. And you're telling me the same thing. You know what? WIG is a new technology. It's lateral to flying. We're rethinking it. And both technologies, by the way, have origins at MIT or Aurora Flight Sciences, which is quite fascinating here.
Absolutely. Cut my teeth at Aurora Flight Sciences and think very highly of that team.
Lovely. Lovely. This has been done before, though. This has been tried before. I believe in the 60s, the Soviets had the Caspian Sea monster. It didn't work commercially. I don't think the Western world has seen anything that scaled as well. What's different about your approach to Seagliders? Why now?
Yeah, it's a really great question. Certainly one that every investor ever has asked us before they've invested. So we've come up with a pretty good answer for this. But I think the unique thing about a Seaglider is that it combines a bunch of different technologies. So it takes that wing and ground history, which I'll talk about in a second, but it combines it with the latest in hydrofoils. It combines it with the latest in electric propulsion. It combines it the latest in digital flight controls and safety systems. But first, looking back at the history of wing and ground craft, you're exactly right. The Soviets, the 1960s, the Akhronoplans, Caspian Sea monster, basically 300-ton flying battleships that flew at 300 miles an hour over the water. Super cool. Worth a Wikipedia deep dive if your listeners have time, because they're pretty incredible machines. Now, what they did prove is that wing and ground works. They could get a much larger machine into the air, much shorter wingspan, more efficient lift. What it also showed are the shortcomings, and really three major shortcomings of all past wing and ground craft that they share: poor wave tolerance, poor maneuverability, and poor safety. So on the wave tolerance first, wing and ground craft, and actually all seaplanes, flying boats in the past, had planing hulls. For the av geeks out there, to bring them up to speed, a planing hull is what you get at the bottom of a speedboat, for example, flat hulls that come up on the surface and sort of skip over the surface as they take off. The other kind of hull is a displacement hull. So that's a canoe where you're sitting in the water and sort of pushing water out of the way.
So what's your typical float plane like? Like a Harbor Air or one of those?
Exactly. So a float plane, if you look at the bottom of the floats, they have slight angles to them, but pretty much they're pretty flat on the bottom, so they can come up on the step, come up on the plane, skip over the water with lower drag to get to that speed to take off. Now, the problem with the flat planing hull is once you have any waves, it gets very bumpy because you're smacking the surface. So at best, it's uncomfortable. At worst, you can't take off at all. And that's actually why seaplanes, flying boats, and wing and ground craft of the past have been really constrained to inland waterways, rivers, lakes, sort of, low wave environment, certainly can't tolerate adverse weather. And that's been a real problem, because if I'm trying to create a transformational mode of mobility, let's say I want to go around the islands of Hawaii, like I'm probably booking my vacation there when the waves are in town because I want to surf them. So, you're going to have some selection bias to the worst case scenario. If I'm in DoD trying to do a medevac mission, if I'm in oil and gas trying to get crew and supplies out to my platforms, they need to operate in all conditions. And so if you only have a foot or two of weather tolerance, you very quickly get out of your operational domain, and this asset is just sitting useless. So wave tolerance is very important. Maneuverability was also very low on these vehicles. They basically need to clear a runway and get off to takeoff speed, which can be well in excess of 100 miles an hour. And in the most crowded waterways, which is where we keep telling investors we're going to operate because that's where the biggest markets are, it actually becomes very unsafe to operate seaplanes in that area. Third, there is the poor safety. Flying at these low speeds flying at these high speeds and low altitudes, you're essentially asking the pilot to land the plane the whole time they're flying. And so their eyes are inside. They're very high workload. We've interviewed them, actually, very high workload. So we fix all three of those problems. We actually fix both the wave tolerance and the maneuverability with that hydrofoil system I alluded to earlier. So Seagliders have three modes of operation: float, foil, and fly. So they start off floating on their hull like a boat. As they move through the inner harbor and away from the marina, Seagliders rise up on hydrofoils. Hydrofoils are underwater wings. We get them from the America's Cup, Sail GP, sort of the advanced yacht racing community. And they lift the Seaglider out of the water, giving us 5 feet of wave tolerance. So now we can operate in 90% plus conditions all around the world and be very reliable. And when we're up on our hydrofoils, we are still a boat. So even though we can go up to 50 miles an hour, the foils are in the water. We've derived this technology from the racing world, so they're extremely maneuverable. So we check those first two boxes: wave tolerance and maneuverability. The final one is safety, and that's where digital flight control systems come in. So now, instead of having a human trying to operate this vehicle, which is simultaneously a boat, a hydrofoil boat, and a wing and ground craft, now you have the system operating this. We have 12 sensors controlling the Seaglider in space and altitude. We have triple redundant computer systems, quadruple redundant power buses, all sorts of redundancy of the fly-by-wire system, so that at the end of the day, you drive a Seaglider like you drive a boat. The only controls available to the operator, who is a mariner and not a pilot, are boat controls, left and right, fast and slow, and the system takes care of the rest.
There's so many things. Thank you so much for that deep dive. This might very well become our trailer in the end, in terms of how this works. So there's so many things to dive into there. But before I do that, I want to understand, how large is this? Your Viceroy craft, how many passengers can it carry? I believe it is going to be the largest electric flying mariner, if that's the category you want to put it in, out there, not an aircraft. How many people will it carry? How far can they go? Give me a sense of range and payloads, perhaps.
Absolutely. Well, we said the economics are driving our vehicles to be larger, and certainly coming, myself and a lot of the founding team from the eVTOL electric aviation community, we saw the economics really want to drive into a larger vehicle that can take more passengers on the commercial side, that can take more payload and more weather on the defense side. So we really wanted to go big from the get-go. So our first vehicle, and the prototype we have on the water right now, is called the Viceroy. That carries 12 passenger and 2 crew, or 3,500 pounds of payload. In the all-electric configuration, the Viceroy will go 180 miles at 180 miles an hour. And we actually recently announced our Regent Defense Division is working on a hybrid version as well. Take out half the batteries, put in a turbo generator, and that vehicle will be able to go 1,600 miles. So the cost and complexity slightly higher, with obviously the gas turbine system on there, but the range significantly longer, and our defense customers are very interested in that. Now, even the Viceroy, as the largest electric machine ever to fly, is our small version. So we're working on a larger version too. That's called the Monarch. That is a 100-passenger vehicle, or about 22,000 pounds of payload. So that's really the size of a regional jet, and is meant to really take a lot of the routes that regional jets or turboprops are flying today, again, along coastlines and between island chains. So we have a family of systems.
Very, very fascinating. You're taking the ferry model, and a ferry can potentially take, small ferries take 100 people, and you're, disrupting aviation. It's very, very fascinating. Do you foresee people being able to drive on to the aircraft like in the ferry in the future?
I think that the drive on probably has more of a role in our logistics and defense customers' use cases, because it's really sort of the size of a regional jet. So we're not flying or we're not driving cars on regional jets today. It's still going to be primarily for foot passenger traffic and cargo missions. In DoD, there is some applicability to having sort of smaller ATV type vehicles, potentially able to do a beach assault or something like that. But in commercial, it's mostly for the foot traffic. And so it represents on the ferry side more of a passenger ferry and the fast ferries, sort of a small passenger ferry. And then on the aviation side, more akin to a regional jet or a regional turboprop.
Fantastic. This is so exciting. I now want to come back to Rhode Island to come check it out. You mentioned something interesting, which was it's not a pilot who would be flying this craft, but instead a mariner. So are you looking at Coast Guard oversight as opposed to FAA certification? And what does this do to certification and timelines? Because eVTOLs, for example, are struggling and getting it certified elsewhere, not in the US because of the workload at FAA.
For sure. Well, that's exactly right. So a Seaglider, being a wing and ground craft, is certificated as a maritime vessel, both in the U.S. and internationally. And so too are the operators certificated as master mariners under Coast Guard law versus pilots. And again, the reason for that is they're really staying in the maritime environment. They're flying below the height of a sailboat mast. It's maritime navigation, maritime, safety of lives at sea, maritime traffic avoidance. It is not navigating airspaces, communicating with tower, and navigating airports. Even though many of our team members are pilots, this is really about the maritime domain. In terms of the certification of the vehicle, actually, wing and ground craft is in U.S. statute already. It's in Title 46 of U.S. Code, where it says, wing and ground craft is a vessel, and sort of continues and goes on and describes it. And then on the international side, there was actually a rule set in 2018 between the IMO, the International Maritime Organization, and ICAO, the International Civil Aviation Organization, that said, hey, this kind of vehicle is sort of between us. How do we regulate it? And so they created 3 different types, they called it, of wing and ground craft. A type A, which is what a Seaglider is, stays in ground effect at all times, dock to dock over water only. So easy, that's IMO. Type B is allowed transient hops up to 500 feet. There's actually a Type B craft under prototype in Korea right now. We have been talking to the senior most levels of both the Coast Guard and the FAA since our founding almost 5 years ago. So we had those conversations early when we were considering Type B craft. FAA wasn't super comfortable with a boat flying at 500 feet, but everyone was very aligned that the Type A craft stays in the maritime domain. And then finally, there's Type C, which is allowed prolonged flight outside of ground effect. So if your listeners saw things like the DARPA Liberty Lifter program or the Boeing Pelican program, some past attempts at wing and ground craft, those are actually Type C craft, which basically means they were airplanes or flying boats. Like they could fly out of ground effect for prolonged time. But very clearly, a Seaglider stays in the ground effect at all times as a Type A WIG, and therefore is under Coast Guard jurisdiction nationally and IMO internationally.
Wow, I had no information around all of these types, so thank you. And the Pelican, yes, that rings a bell. I know the aircraft side of things. What about? I know there's a pilot shortage. Pilot pays are through the roof. Do you also luck out on ship captains? What is the supply there like? Are these unionized? How does this work?
Yeah, well, that was one of the problems, and one of the insights we had coming from the eVTOL world was that there's a lot of hard stuff in bringing the eVTOLs to market. And I think they're incredibly cool machines, but you have the range, you have the certification, you have the infrastructure, you have the crewing. And how are we going to bring thousands of more aircraft into our airspace without significant autonomy, which represents its own challenge, where we're already facing a pilot shortage? You have the 1,500-hour rule for commercial pilots, and then COVID made everything even worse because all of the older pilots retired and were given great packages to retire. Then air travel came back with a vengeance. We're actually way past our 2019 travel highs now. So the market has totally recovered, like COVID wasn't even there. But now all those pilots are gone. So the majors come in and recruit from the regionals and say, we'll pay you more. And so while we have a pilot shortage, the pilot shortage is worst on the regional routes, which are painful anyways. And so that is really sort of a secondary advantage of Seagliders. Not only are they, cheaper and greener because they're all electric, and we can do these ranges flying in the efficiency of the ground effect in our all electric battery version. We can go 180 miles today and, up to 300 to 400 as battery technology improves. But also we now have access to this much wider swath of master mariners, of professional mariners, people that would, drive a passenger ferry or things like that, can take a Regent Seaglider course. It's only about 6 weeks of training that Regent will offer, get their credential as a Seaglider captain. And so now we can solve the most painful point of the pilot shortage as well, which is the regional routes.
Wow, fascinating. I believe, correct me if I'm wrong, Mesa Airlines has invested in you or has ordered planes. So are you looking to disrupt regional aviation or supercharge ferry services, or both?
Yes, we are. Exactly. And I think that was a interesting approach. The conventional wisdom is focus on your one core customer, your ideal customer profile, and sort of ignore all other customers until you really land that one early on. And we said, look, our customer is someone trying to travel on a regional coastal route. And it just so happens that some of those customers operate ferries today. Some of those customers operate aircrafts. Some of those customers are driving buses and operating rail and flying helicopters. And so our ideal customer profile, they actually just had to use the tools at their disposal today because they don't have Seagliders. And so the answer is yes. We have, our order book, we have $10 billion in our backlog, and it really bifurcates between the maritime side that are looking for, faster, greener ways of travel where they can leverage their existing docks and crew and even routes. And then the other half is on the aviation side, where they want something that is cheaper and greener. And, the airlines are going to sort of figure out how to navigate and operate with a boat with mariners, but it actually solves a lot of problems in the most challenging part of their network.
Building on the commercial bit, you've got, did I read it right? $9 billion in orders from around the world. What is driving this demand? And perhaps give me a few use cases of how customers are actually going to be using this craft. I wouldn't call it aircraft, the craft.
For sure. Well, actually, we're up to over 10 billion now, which is very exciting.
Wow.
And that's just on the commercial side, I should say. And that is not even speaking about, our $15 million with the Marine Corps contract and our rapid pace to an acquisitions program right now, which will drive that number even higher. But focusing on the commercial side for a second, think about the U.S., really the four corners of the U.S. And so, we announced a big order from Urban Link down in southern Florida that can do multiple missions there. The Seaglider can do a commuter mission from West Palm Beach to Miami. I have family in West Palm and business in Miami, so I've actually driven that route a bunch. That can be 2 hours with traffic. So you can do a commuter mission like that, but you can also do more of your recreational or sort of vacationer mission, which would be Miami to the Bahamas or Miami to Key West. Either way, that's a 4-hour mission plus, whether you're driving or taking a ferry. Seagliders will do it in about an hour. So really great different missions there. We have some great investment and customers in the Middle East, so spend some time out there. Dubai, Abu Dhabi is actually a sort of a similar route. If you really go fast with no traffic, maybe an hour, more like an hour and a half. And then
I've never done it in an hour.
It's like two plus. Getting into Dubai will just take you a half hour just from the outer city limits wherever you want to go. So in this case, again, the majority of the world lives in these coastal communities. Both of them are coastal, and so you can take a Seaglider in between for a small fraction of the time. We're talking about a half hour. We're talking about tickets that are $100 or less, and so it is essentially high-speed rail without the billions of dollars in rail infrastructure around the world. So imagine just fitting every coastline around the world with a high-speed rail system that is Seaglider instead of rail. I'll give you actually one more. So we're working with some oil and gas and some energy companies on both oil and gas and wind energy. Both happen to be
Orsted.
out in DC.
Orsted is one of the customers in Norway.
Exactly. Yeah. So we have partnerships with Orsted and with Total Energies. Recently announced with ADNOC, the Abu Dhabi National Oil and Gas Company, that we're doing a pilot program with them with real testing. And so in these cases, again, helicopters are very expensive to get out there, require tons of training, huge maintenance costs, safety implications of flying helicopters over the water. And in our case, we can fly something out there for a fraction of the cost, fraction of the time, higher safety. And what I think is really cool, and for some of these energy companies as we undergo the energy transition, is we can also do it in a more sustainable way too, and we can help them take that step into sort of the next generation of energy.
Wow, my mind is blown. You mentioned urban link, so let's dive a little deeper into that. I believe they want to do Florida to Puerto Rico, or Miami to West Palm Beach, right? 35 minutes, but they want to serve 4 million passengers annually for a completely new category of transport. Have you, forecasted or looked at what might be the blind spots? What can go wrong when somebody tries to scale up to 4 million passengers annually? How do you handle that kind of operation?
For sure. Well, I think one of the biggest case studies and frankly warnings for implementing a new mode of transportation and then trying to go very fast to scale is actually the super ferry in Hawaii. It actually sort of the concept makes sense. Right now, the only way to get between islands in Hawaii is to fly. And so Super Ferry said, we're going to bring a big passenger ferry and we're going to go in between the islands. The problem is they really didn't ask anyone how this works, how they felt about it, what are the problems. They just bulldozed this in. They basically pissed off everyone. First off, they stole a lot of inter-island traffic from airlines and rental car companies. And so there wasn't a lot of friendliness there because now they were competitive. And then from an environmental perspective, they actually circumvented their environmental impact study. So they did not have data on how it would impact, the whales and the rich, maritime life there. They did not spend a lot of time with the communities asking their specific concerns. And at the end of the day, it was really the community who literally, was sitting in front of Super Ferry on their surfboard saying, this is not wanted here. You guys have circumvented our channels. And the operation, went bellies up. And so when we came to Hawaii, and we've been working in Hawaii for years now, Hawaiian Airlines is an investor, Mukulele's placed orders. We've said, we are going to take the exact opposite approach. We're going to listen first. We went on a listening tour around the state, 200 plus meetings, all these different community groups, local groups, tourism groups, government and state entities, your land and natural resources, your energy commission, everyone, and said, this is what we want to do. And in the event where it scales, and these are going all over the place and taking the majority of that inter-island traffic in Hawaii, 7 million passengers a year today, and that only represents 20% of inter-island traffic. So we could be talking 30 plus million passengers a year. In the success case, what are the concerns and how does this work? And so that actually turned into an initiative, which is called the Hawaii Seaglider Initiative. And you can see that at HawaiiSeaglider.org, where basically now we formed this coalition where all of these groups are now together voicing their problems, focused on the different challenges. So the sort of main answer, getting back to your question, is that it is not one size fits all. It's very market specific. And now we've sort of taken the lessons from Hawaii's Seaglider Initiative, scaled it all over the world. We were working on Japan's Seaglider Initiative, Miami Seaglider Initiative, Rhode Island Seaglider Initiative up here at home, where we can learn what the local problems are, what are the local issues that will affect scale, and sort of tackle those and develop buy-in before the first Seaglider ever shows up at the dock.
Wow. I love the listen first approach. There have been so many times, ambition takes over and vision sometimes takes over, but listening is where you want to start. And I've heard great things about you from Hawaiian as well, for the record. So you come multiple recommended to come on the podcast. So I'm glad we're doing it. One advantage you just mentioned is infrastructure. You don't need new infrastructure. Is it really plug and play? You can just use any dock and you don't need, like vertiports for eVTOLs or even new gates for A380s when we had the new aircraft back in
Right.
the day, decade ago. Or are there any hidden complexities? Anything that existing infrastructure providers need to modify to accommodate a sea glider?
Yeah, so it starts off that we can use existing docks, and I think in the early days of sea glider operations, we in most cases we will. Of course, on the commercial side, we're an electric vehicle or battery powered, so you need chargers at the docks. Fortunately, there's a lot of great tailwinds there. The ferry industry in Europe has had a lot of government investment in electrification of the ports, and even in the U.S., you look at a place like Port Miami. And when the cruise ships come in, the port doesn't want the cruise ships burning their dirty bunker fuel in the ports. And so there's actually a big effort to put in dozens of megawatts of power in Miami so you can plug in the cruise ships for their hotel power overnight, and the sea gliders can tap off those lines to charge the sea glider. So you need a charger, and that may be modification in some parts of the world, which you could solve with either tapping into the grid if it's available or leveraging local microgrids, which works as well. But the dock itself can actually be very simple. And if you look at some of the videos of our test operations in Rhode Island, it's just sort of a wooden finger dock, and the sea glider pulls up to it. Now, I would say this does not scale into the transformational, new mode of mobility. There will obviously need to be new dock constructions in some places so that we're not competing with marinas and things like that. But we have several designs for how you could sort of geographically configure the sea glider so their wingspan isn't a problem and you can optimally use docks. And one of the nice things about sea gliders versus an aircraft is you can just park them in the water. You can moor them. So you can put your fleet and sort of have your fleet floating away from the dock, and then you can only come up to dock when you want to charge or whether you want to bring passengers on and off. Additionally, and in defense, the main mission in defense is to go into these austere environments and, expeditionary advanced space operations, which is what the Marine Corps calls it. There may not be anything there or very little. And so that's
No
why.
infrastructure at all.
Exactly, right. You just maybe dropping something off and going. So, a few things that we're taking to approach that there. One is that hybridization, which gives us much longer range, so we don't need to charge. The other is a sea glider is actually designed with a very shallow draft. That is how deep the boat goes in the water. So we only have a 4-foot draft when we retract those foils, which means we can get very near to beaches and we can go a lot of places that a much bigger boat cannot. So for both of those reasons, on the defense side, we want to be able to go into the austere environments. In the commercial side, we want to be able to start with existing docks so there's low overhead. Everyone realizes how amazing sea gliders are, and then there will be more efforts to build out docks. And when we do, obviously we take the lessons we learned from Super Ferry and we undergo the EIS and we do the proper approvals in every place we do it.
Amazing. I'm glad you have thought through this thing because that often, it turns out to be a blind spot for some people. And I'm glad you're thinking through that. Let's talk about some of the trials. If I'm not wrong, this summer, you flew the plane yourself. How did it feel? I wouldn't say plane. A sea glider. I need to correct myself. This is not an aircraft.
Yeah, well, I appreciate that. No, so it's been a super exciting summer. We are under sea trials of our full-scale prototype right now, of the Viceroy prototype. So this is a 15,000-pound vehicle with a 65-foot wingspan, powered entirely by batteries, with humans on board from day one. And you're absolutely right. So, mid-August, my co-founder and I hopped on board and went through all of the test operations, working with the test team, rapidly approaching flight here. So we got to float, we got to foil. We're still working on improving our speed up to flight. But it's funny, in the maritime world, they call hydrofoiling boats flying boats. Like, we are a true flying boat because we'll leave the water in the ground effect. But I tell you, it does feel like when you're on the foil, it does, even on the foil, feels like you're flying. It's pretty amazing to just press that, mode up button from float to foil, and the waves just go away, and you're just floating, and that vehicle's locked in almost like you're riding on rails over the water. So it's just an incredible passenger experience, incredible operator experience. But I was also just so struck by our control methodology. This is an incredibly complicated vehicle, fly-by-wire, all these redundancies, all these moving surfaces, etc. And all we do as the operator is exactly as we dreamed it up 5 years ago. It's left and right and fast and slow. So it just felt like I was taking my boat out on Narragansett Bay, even though I'm in this massive vehicle suspended on foil. So it was just an incredible experience. But I'll tell you, it does certainly, when you're sitting your butt in the thing, it certainly makes you very keyed in on what's our safety analysis, what are our redundancies, have we gone through this with the right rigor and meticulousness to catch things. But I think as co-founder and CEO, like that is important, that I'm willing to sign myself up and put myself on board. So I'm
Wow.
extremely confident.
Were you nervous when you pushed the throttle up yourself?
I was excited, man. I like it was just so cool. This team is absolutely incredible. Like we have the best boat builders, the best aerospace engineers in the whole planet working here. I'd seen, obviously, we had gone through, we're very systematic in the test. So it wasn't like we just put it in the water and started ripping on the foils. That was the result of several months of test campaign where we very slowly worked up in speed on the hull, worked up on the foils, to very low altitude, slowly got to that 5 foot altitude on the foils, increase in speed. So I knew I was going into a robust system, and I was also very familiar with the sort of technical rigor behind it.
Wow, 5 years, huh? Just 5 years, not 10 billion in orders, commercial applications from Neom to Japan to Orsted. Um, how has the journey been? Is this the dream run you had ever dreamed of, Billy?
Oh man, well, we're having a lot of fun, that's for sure. I think Mike and I and the whole team, we wanted to build something that changed the world, and that was sort of that was one thing that was missing in some of our early engineering development. Both of us were aerospace engineers. I've since become a little bit corporate bobblehead, but still like to spend a lot of time in the technical world. That's where I'm happy. So, we came from this world, and you work your nights and weekends, and your amazing, cool airplane prototype ends up in a museum somewhere. And it's like, no, like we need to build something that changes the world, changes how people move and live and travel, and something that we're going to use. So it has been a lot of work, and those 5 years have gone by pretty quickly. But like this is just the coolest job in the world. I wouldn't do anything different.
Wow, wow. Well, you've worked at Virgin Galactic, Blue Origin. You've done this Aero Astro, of course, and Aurora Flight Labs eVTOL program you led. What's different this time, Billy, for you personally?
Yeah, I think how clear the end game is, and how clear the vision is. And I think sometimes engineers burning the midnight oil working on a problem so deep in the technical weeds, and sometimes you lose that connection of like, this is fun, but like, why am I doing this other than it's fun or it's cool or this thing goes fast or whatever. And so it has been so amazing to me. We put this out into the world, and then our customers start telling us ways that they're going to use it that we didn't even think of. We started working. We have a customer in New Zealand with Ocean Flyer, and then typhoons hit New Zealand, and coastal communities were really affected because there's only one road that went to these places, and the road was flooded, and so these communities couldn't get out. The same thing that happened with the earthquakes in Japan, the same thing that happened with the fires in Maui. So they said, hey, we can actually use this for disaster relief and medevac and saving people. We had a member of the Hawaii Seaglider initiative, Healthy Mothers, Healthy Babies. And originally I was like, well, that's cool, but like, why is Healthy Mothers, Healthy Babies signing up for the Hawaii Seaglider initiative? And they said, like, even today in 2025, mothers on some of the less available islands or more remote islands like Molokai don't have access to the medical care that they need. Even today, there's only a couple flights in every day. You can't get on. And so like that just blew my mind that in 2025, we still have people literally stuck on an island, and Seagliders could, increase their access to care. And so like, yes, I wanted to solve that Boston, New York mission. Like, yes, we wanted to solve contested logistics in the Indo-Pacific, which is the main theater where we see, geopolitical tensions. Like those are sort of the obvious ones, but then this kept growing. And so as an engineer working on this thing, it's just so cool to say like, this thing that I'm working on is not only really cool in the moment for the vehicle it is, but it's going to have this, huge impact on the world. And I think that's what helps us move so quickly and have so much passion on the team.
I love it. I have a suggestion. You should approach Disney, because for Moana 3,
Yes.
Moana should be riding a sea glider
Yes.
rather than a boat.
I love it. All right. We're going to network our way there. If anyone's at Disney listening, give me a call.
Moana 3, she rides a sea glider. I love this. I love the story, and I wish you great success. The last part of this podcast is where we get to know you a bit more personally. And I think we've already made this quite personal, but it's rapid fire round. So you can only answer me in one word or a short phrase. So simple thing, like your favorite book.
The Right Stuff.
The Right Stuff. Okay.
Right Stuff. Oh,
Easy. Favorite movie?
Favorite movie. Oh, man. I should have prepared more for this one.
No, you can't.
Okay, come back to this one. One.
No, if not Top Gun, maybe Moana.
I was thinking it's somewhere between Top Gun and Moana, I would say.
Hilarious. Favorite city?
Favorite city. Honestly, I grew up in Boston. I have a lot of love for that city, but in Rhode Island now, and Providence is really charming. So big fan of both.
Love it. Favorite airline?
Airline. I'm going to bring it back actually and go Pan Am. Not that I ever got to fly it, but just looking back, the travel posters, the Clipper, the elegance of the flying boats, we're sort of bringing that back now at Regent.
Nice. What do you do in your free time?
Typically work, but other than that, love going outside. I used to fly a little more than I do now. That was a lot of fun. I've been trying to get more into water sports and skiing in Rhode Island. So my co-founder and I and my wife and some of the others at the company will go out surfing, which has been a lot of fun.
Nice. Well, if I did my research right, didn't you start this jockey startup back in the day? Weren't you a DJ? Do you still DJ?
That was my first entrepreneurial venture. Yes, I was a DJ. I was actually the MC. Yeah. So I'd host. That's where I got my stage presence. You got to be able to think on your feet when the 13-year-olds aren't doing the dance,
Got it. What is something you'd like to learn?
Something I'd like to learn. I have so much respect for the manufacturing companies of the world, particularly those making vehicles, that people are, when you step in a car, when you step on an airplane, you are trusting your life to that vehicle manufacturer. And so I think there's just so much tied up in that process. I'm really excited for the next phase of Regent now that we're, getting through prototyping and test and into manufacturing to really learn what does it take to build that globally distributed supply chain delivery system, a quality assurance system so that people trust your product.
Love it. And final couple of questions. If we are speaking 1 year from now and we are popping champagne, what are we celebrating? 1
year from now. So that would be summer of 2026. Summer of 2026, we're getting pretty close to the first Viceroys coming off the line and actually starting their sea trial. So I'd say we will have achieved the very first classification. That's something that large ships go through. Seagliders, we're going to have the first wing and ground effect classification from these maritime societies. So we'll either be cheersing having just achieved that or having just, had the first Seaglider off the line about to start the sea trials.
Amazing. Billy, it was such a pleasure speaking with you. I am absolutely loving. Actually, I mentioned Mark Allen earlier. There's also Brian Yutko from the same gang who's doing big stuff over at Wisk and now Boeing. So it's been fantastic just to see the conversions and now, how you're all three expanding aviation in your ways. Love the journey. Loved recategorizing. I didn't ask half my question because you're no longer an airline or an airplane. So loved that you have, you're recasting this entire conversation and yet still making aviation more sustainable. I wish you all the best.
Absolutely. Thanks so much, Shashank. This is really great.
Thank you for listening to this episode of Sustainability in the Air. Aviation is one of the hardest to decarbonize industries, yet there are multiple paths to get to net zero. Awareness is key to a green future. So please give us your support to help our sustainable aviation insights reach a wider audience. You can do this by sharing this episode on your network, on LinkedIn, Twitter, or even WhatsApp. Or perhaps you might consider leaving a review on Apple Podcasts, Spotify, or wherever you listen to this episode. You can start a conversation with us by writing to us at podcast@simplifying, that's simply with an I.com. And for more content on sustainable aviation, please visit our website green.simplifying.com and join the movement. Sustainability in the Air is an original podcast by Simplifying. The show is produced by Juraj Toth in Slovakia. Dirk Singer is our Director of Sustainability, who leads research for each interviewee out of Greenwich, UK. Shubhadeep Pal is our Supervising Editor based out of Mumbai and Singapore. The articles are written by Ayushi Badola in Dehradun in India and Meera Hull in Montreal, Quebec. Creative design is led by Ligia Esteve in Montreal. Baiba Drimain is the project director for the show based out of Valencia, Spain. Special thanks to Wendy Sim in Singapore. And I'm Shashank Nigam, the CEO of Simplifying and your host. Please feel free to connect with me on LinkedIn.